Hi everyone, this is Paul Soto. I'm going to present my final project, which is the marathon PB prediction, taking in consideration some characteristic of the runners and which will be the best characteristic for the marathon PB prediction. I just take some Boston Marathon results from 2015 to 2017. I just gonna resume. I'm gonna make the summary of the all the week by week or of all my project. Here is the project overview and the research question. So the research question was what runner characteristic prior race feature best predict whether a runner will achieve a personal best and by how much. So the problem was the most of the runners wants to do a PB in every week, in every run. So they would like to improve, and I'm analyze this data to know which will be the best characteristics to predict this improvement in their marathons. So the data set that I get is the Boston Marathon from 2015 and to 2017, as I mentioned it before. There is more than 79,000 records with 9 split columns, which they contains the finish time, the age, the gender, the country, and it will be those are merged in just 3 years. The methods that I apply is in the all these 6 week pipeline. It was the first I get the data, then I get the ADI, then I feature engineering. Then I made the regression analysis and the classification, and then I just assemble the models and finally the evaluation. The best result was uh, the gradient-based model, which was one of the models is the number one predictor for this question for this project, and it has a 43.9% of importance. I'm gonna show you this in the next slides. Okay, so in the first week, what I did is I just cleaned all this data in one data set because I have more than 2 years. I have 3 years in the data, so three CSV files, and then I just make some analysis from these runners because from these 79,000 there were like 12,000 who ran more than one time in the Boston Marathon from these years. But they also ran more than twice this marathon in those years. And I just find 9,000, more than 9,000 unique runners. So I just analyze those 9,000 from the whole population. Then I just have uh, time columns because they were split in 5K to 10K. There are some analysis in there. Also, I took this in consideration, and also I just changed the time from hours, minutes, and seconds to just seconds because I just want to analyze the improvement in seconds. Some of the pipelines that I made it, they are mentioned here. But I also has to made some variables which I constructed because according to my analytics, I need some new variables. Like for example, improvement seconds. Uh, there was the prior finish time minus the current finish time. In the positive, it will be faster. For example, I have the improvement PCT, which was the improvement as a percentage of the prior finish time. Also, I have the ISPB, which was one if the new personal best was a binary target. Also, I have the pacing ratio, which I consider this for the second half of the marathon. over the first half of the marathon was greater than 1. I take this as a positive split. As I mentioned it in my last video, this was one of my best characteristic for the prediction of the marathon. All right, so in this slide, what I have is the exploratory data analysis, uh, taking patterns like age, gender, and pacing, which I find this really interesting. I showed you that before, but I want to emphasize that here is that like 29.8% of the runners run faster versus their prior rise. 25.6% they made the personal best rate of all transition. Most of the runners they slow down their marathons, so it's like they made 7 minutes slower than their previous marathon. Also, the correlation improvement was for the pacing was negative 0.50. Uh, so as I mentioned before, the pacing was the strongest signal for the prediction of the best marathon. So my analysis showed that uh, if you run the first quarter part of the marathon, then you can. This is a strongest prediction for your personal best. If you run fast the first part of the marathon, most of the runners they just slow down and very drastically, like negative 2000 seconds in the last part of the marathon. Some people who run here, I read that in the first presentation, they can understand this is the wall in the marathon. So this is the last part of the marathon. According to the increase of the age, when you are getting older, also is a predictor of the decrease of your time in the marathon. Uh, taking in consideration about the gender, women they have more personal best, uh, taking sex in consideration. They have more percentage of personal best than men. Uh, okay, then I constructed some feature engineering for this baseline regression for my regression model. So in this part, I just take the runner profile, which I consider some information. Then I took the prior rise, taking some radius, some pace, and the prior finish time. Then I converted this to my split deliberate, like the lab CV. I created this variable for every 5K that I consider. Then I made the fail ratio, which was the last over the first lap. So taking the first 5K over the last 5K. And then I just create the year 2016 and 17 for the race year dummies. So I just splitted all this information and then I make my linear regression analysis. And so the baseline result, which I'm looking here, is that the dummy air SA it was 1,370 seconds. So this is the error if you always predict the average for every runner. So it's like 22 minutes. Uh, then the linear regression model, it was at the air SA, it was 1.061 seconds. Then the air squared, it was 0.399, and the linear model regressor error to 17.7 minutes. And this explains like the variance uh, was 40%. That was a strong baseline showing the features carry by real signal. So the last one, the logistic regression AOC, it was 0.808. So this is the classifier correctly ranks a free personal base race above to the known personal base of the time. Okay, and the week four, I just ran the last model that I had to analyze. It was the random forest and the gradient boosting. So I just trained two more powerful algorithms on the exact same 10 features from all the weeks that I was working before, because the key question was whether nonlinear models could improve or on linear regression by capturing interactions between features that a straight line cannot represent. So these two algorithms. But why these two algorithms? Because random forest builds hundreds of independent decision trees, each trained on a random subset of the data. Then they average their predictions. This reduces the overfitting on handles nonlinear relationships naturally. And the gradient boosting builds decision trees sequentially, so each new tree corrects the errors of the previous one. With a low learning rate on many trees, it gradually hones in on the best predictions. So, analyzing right now this chart, the as you can see, all the models they were with different numbers. So the dummy model, it was 1,370 seconds, which is the floor. And then I analyzed the improvement from the linear regression, which it was 1061, to the gradient boosting, which it was 1031 seconds, and the improvement is 31 seconds. So about the 2.8% of the models in the absolute terms, but confirmed by cross validation as real, not random variation. And then taking these numbers, I'm sorry, the difference between these models are very small, meaning that the features are doing the most of the work. The algorithm choice matters less than having good predictors. So this was for this week. And finally, I get this in the finally week, the model and evaluation for the feature importance. In this evaluation that I make is that taking in consideration one of the variables that I make is that the lab CB, it was within the number one predictor of the personal best in the marathon, because it represents the 43.9% of the prediction. This analyze that the first 5K is the the best prediction, because if you run the first part of the marathon uh, in the slow pace, it will allows you to improve your final time in the marathon. Then the number two was the prior finish. So slower runners, they have more chance to improve the marathon than the fastest runners. They almost are in the ceiling of their career. The number two is the pacing ratio. So the 11.3% is really important because once you over run the first half uh, slow, and then the second half you run this really quick, like a positive split. So it's a number three predictor of the personal best. And the prior pace also they has like 8.9% of the prediction. That was one of my analyze. Here in the left is all the variables that I take, and as you can see, the lab CB, the variable that I make, is the best predictor for this project. So this week was the final results, and this is the dashboard that I make the summary of all my presentations. So uh, the best root mean squared error was 1031 seconds. It this was for the gradient based model. The regressor predicts that that was the best model for all my my analysis. The best error score, it was 0.433. It means that the 43.3% of the variances explain it. As you could see, my project, it belongs to one of the variables for the predictions. The best AUC also was 0.814. It also represent for the gradient base model for the PV classifier, and the reduction for the mean baseline was for the dummy. So it's the final result. Here is all the models that I take in consideration. As you can see, the first just was the analyze, but for all my analysis, the best model was the gradient boosting, which the lab CB is the number one prediction. As I mentioned, is the taking every 5K to 5K as a predictor, considering the first 5K as slow as the next one. Even the split runners, the average uh, more than 60 seconds versus the blown up runners average negative 1.583 seconds. So finally, the conclusions for this project, they are the next. So the pacing consistency as like my variable, the lab CB, is the number one predictor. It predicts you the improve in your next marathon time. This is the taking every 5K to 5K from slow to fast, starting from the slow to the fast at the end. So the gradient boosting outperforms all baselines. So taking these numbers is a good predictor for this analysis as a PV classification, as a personal best. Even the split runners, the first quarter average, they have the if they slow this first quarter of the marathon, it they has like more than 67 seconds of improvement in the next marathon. And they have the blow up runners who start really fast, and they just uh, lost a lot of time in the last part because they started too fast, and they just go down to the last part because it's a bad idea to do that. Another conclusion is that women achieve the personal best more often than men. Also, the age effect is real, but is a modest after Bayesian is controlled. The linear baseline captures 40% of variance. Ensemble models add a further 3.4 R square percentage points. And the five-fold CB RMSE is the closely matches to the test. Like the model generalizes well. And thank you so much for all your attention. I really appreciate your time. I really learned a lot, and thank you for your patience. Have a good day, guys.